Okay, everybody, so today in class we had started chapter 7 and we talked more about the coordinate plane, which we're going to be doing a lot of in the next couple of weeks. And so let's just review a little bit of what we talked about. We talked about this coordinate plane, which was a number line going left to right and a number line going up down. We called the left right the x-axis. We called that line the x-axis. We called the one going up down the y-axis. Okay, so we also talked about the quadrants of the coordinate plane. This is quadrant 1, so this whole first, right side. This over here is quadrant 2. Over to the bottom, kind of rotate counterclockwise. This is quadrant 3, and this is quadrant 4. We also talked about a coordinate point being an x and a y, and it would be in the form, we put it in parentheses, the x coordinate, so the number along the x-axis would go first, and the number along the y-axis would go second. So let's see what we can do based on that. So it says name the quadrant each coordinate point below is located. So we have the point 4, -5. So the x coordinate is 4, the y coordinate is -5. So we go over to the x coordinate of 4, we go down to -5. I'm actually going to plot that point for you. There's 4, -5. And that would be in quadrant 4. Okay? Actually, let me switch back to this view so we can see everything. Okay, so now we've got the coordinate point 2, 2. What quadrant would the coordinate point 2, 2 be in? So again, remember, it's an x, y coordinate. We go over to 2, we go up to 2. So there is the coordinate point 2, 2. So we would say that's in quadrant 1. Good. And we are going to use the Roman numerals for the quadrants, okay? All right, a couple more. -1, -3. Okay, so now we've got both negative points. So -1, we go along the x, so we're going to go to the left if it's negative, and we're going to go down to -3 because it's negative. I'm going to plot that point, -1, -3, and so he would be in quadrant 3. Now since you're taking your own notes, I want to make sure that you've got a coordinate plane plotted. You've got the coordinate points we were talking about here, and you're labeling with the appropriate coordinate point, okay? All right, next one, -6, 1. All right, so we've got an xy coordinate point. The x is negative, the y is positive, so that means I'm going to go over to the left to -6 and up to 1. So right there, 6, 1, I plot the point, and that is in coordinate quadrant 2. Okay, the last one I want you guys to look at and consider is -4, 0. -4, 0. Okay, so the x is negative because it's an xy coordinate, and the y is just 0. So I go to -4. So 1, 2, 3, 4. That's right on the axis. So do we say it's in 2 or do we say it's in 3? We actually don't say anything. It is not in a quadrant. It is on the x-axis. Okay, so I will give you a second to write that. Again, you're going to say it is not in a quadrant, it is on the x-axis. All right, got it? All right, we're going to move on. So I could also ask you guys to give the coordinates of a point. Now look, I gave you a blank coordinate plane here with no numbers labeled. We talked in class that usually we're going to make each unit 1. But I could make this a unit 5. I could say each line is 5, 10, 20. That's going to be up to you and to our graphs that we're working with. But for now, we're going to look at a coordinate plane where each line represents 1 unit. So this would be 1, 2, 3. This would be -1, -2, -3, and so on. Again, we've got our x-axis and our y-axis, and I've got the coordinate point B. If we want to tell the point that it represents, we know we need an x and a y. X always goes first, so we're going to count over. 1, 2, 3, 4. But we went left, which is in the negative direction, so that is actually -4. And on the y, we went up in the positive, so it went up 1 and 2, so the coordinate point is -4, 2. Okay? All right. And moving on. So you guys have spent some time over the last couple of years working on coordinate points. We also want to make sure that we know how to tell if something is a solution to an equation using a coordinate point. So for example, is the coordinate point 3, -1 a solution to the equation 4x plus 3y equals 10? Well, notice that the equation has two variables in it, and so what we're going to do is we're actually going to substitute the values in to the equation and see if the equation is a true statement. Okay, so since this is an xy, I'm going to plug in 3 for x and -1 for y. So watch, 4 times 3. Anytime we plug a number into an equation, it must be put in parentheses. Okay, so then we've got plus 3 times -1 equals 10. If you don't put it in parentheses, what's going to happen is you could have an issue with your negatives and positives. So we've got to be really careful. Anytime we plug something into an equation, go ahead and put it in parentheses. All right, then we see if the left equals the right. So we get 12. 3 times -1 gives me -3, so minus 3. Does that equal 10? Well, 12 minus 3 is 9. So does 9 equal 10? No, it doesn't. So no, 3 -1 is not a solution. Okay, and we've been working on checking solutions and checking our answers in our previous chapter. Let's try another one. Ooh, what did I throw at you this time? I threw fractions. The process is still exactly the same. We substitute the values in for x and y and we solve. So we get 4. Anytime we plug something in, we're going to go ahead and put it in parentheses. And I'm going to go ahead and write my xy above so I don't forget. So 3/2 plus 3 times, parentheses, 4/3. Does it equal 10? Ooh. So now, Coach Fred always says, simplify then multiply. We remember this is over 1 and this is over 1. 2 goes into 4 2 times. I've simplified, now I multiply. So 2 times 3 is 6. 1 times 1 is 1, so we just write it as 6 over 1, we would write as 6. Okay, go over to the other one. Simplify, then multiply. 3 goes into 3 1 time, okay? 1 times 4 is 4. 1 on the bottom we would leave, okay? All right, so does 6 plus 4 equal 10? It does. So yes, 3/2, 4/3 is a solution to the equation. Okay, is 3/7 a solution to the equation y equals 2x plus 1? You go ahead and do it on your paper, and I'll be doing it as you are. All right, so I'm going to go ahead and plug it in. I'm going to plug in my x and my y. Now, it's in a different form this time. Y is on one side of the equals, so 7 equals 2 times 3 plus 1. Okay, so 7 equals 6 plus 1. Yes, 6 plus 1 is 7, so 7 does equal 7. So yes, it's a solution to the equation that we just came up with. All right, now we have to think a little bit harder. Could we find 3 other solutions to the equation? Well, how do we do that? That's slightly different, and we haven't spent a lot of time on this because we haven't been working on tables of values or anything like that. But what we can do is we can actually substitute in values of x and solve for y. Okay, so what do I mean by that? We're going to let x be, how about 1? Okay, we're going to let x be 1. So, if x is 1, we get y equals 2 times 1 plus 1. So y equals, 2 times 1 is 2, so 2 plus 1, so y equals 3. So the coordinate point, x of 1, y of 3, is a solution to the equation. Okay? Let's pick another x point. Let's pick the x point of 0, okay? So y equals 2 times 0 plus 1. 2 times 0 is 0, so y equals 0 plus 1, so y equals 1. So the coordinate point 0, 1 is a solution to the equation. And you can do this for any x point. Plug in any x you want, solve for y. Any x you want, solve for y. So I'd like you guys to come into class tomorrow with another solution. So find another solution. Okay? Don't forget. All right, so let's move on. The next thing that we're going to be talking about is graphing in two variables, okay? So the graphing part of this gets a little interesting. Any equation with two variables can be graphed by creating something we call a table of values. A table of values is, again, a little table that we're going to create for us. We're going to have an x on the left and a y on the right. And I also like to call them an xy chart. Now we're going to use that concept of finding solutions to find some points on the graph, and then we're going to actually graph this. Now remember, we talked a little bit about just plugging in values, so you're going to be really neat here. So we're going to plug in 5 values. I want 5 values on every graph that we do. So, unless I specify otherwise, okay? All right, so we're going to use the points -2, -1, 0, 1, and 2. Now, I want you to do the work with me, okay? So if we let x be -2, we get y minus parentheses -2 equals 1. Now, this is where that parentheses is really important because look, now I have a negative times a negative. So this becomes y plus 2 equals 1. We solve for y by subtracting 2 to both sides, and we get y equals -1. So that coordinate is -1. So the coordinate point -2, -1 is on the graph of this line. All right, let's try another one. -1, so we have y minus -1 equals 1. We get y plus 1 equals 1 because negative times negative gives me positive. So y, we subtract 1 from both sides, and we get y equals 0. Okay, so we're going to plug in that 0 into the table. Keep going. We get y minus 0 equals 1, so y just equals 1 when x is 0. All right, keep going. Y minus, it's a positive 1, so we just plug in 1 equals 1. So we are going to add 1 to both sides, so y equals 2 when x equals 1. And one more, and I'm going to do it, I'm going to scroll up a little bit. Okay, so we're going to do y minus 2 equals 1. So we add 2 to both sides, and y equals 3. Okay, so now we're going to take those points, and I'd like you to go ahead and create yourself a coordinate plane. Like I said in class, it'd be really great if you could get those little post-it notes from the bookstore, and they will help you make really nice planes. If not, I want you using a ruler. So in class, I'm going to be giving you rulers each day to use, but at home you're going to want to have a ruler handy when you're doing your notes and your videos. Okay, so we're going to plot the point. -2, -1. So -2, -1. -1, 0. 0, 1. So x is 0, y is 1. X is 1, y is 2. And then x is 2, y is 3. That looks really, really nice. I'm going to actually connect them, and you're going to see that that forms a very nice line. Okay? All right, let's keep going. One more. Your turn. I want you to try this one. I'd like you to create a table of values and then graph the equation on the coordinate plane. Your graph is the equation 6x plus 2y equals 4. Now I want you to do this as neatly as you can. Again, it's 6x plus 2y equals 4. I do want you to plug in the points. The 5 points I want you to plug in are -2, -1, 0, 1, and 2. And so go ahead and do that work. I want you to press pause, and then I want you to come back and check your answer. So I do want you to press pause. Okay? All right, so you've pressed pause, you did your graph. The y points you should have gotten were 8, 5, 2, -1, and -4. Okay? You plot those points. -2, 8. Okay, so now my graph doesn't have it on there, but yours, because you made your own, will. So I'm going to go way down here, -2, -2, 8 up here. So right here. And then -1, 5, and then 0, 2, and then 1, negative 1, and then 2, negative 4. And again, you graphed it, and you should have a nice line like that. Okay? All right, guys, so I want to make sure that you have all this for your notes tomorrow. I will be checking when you get into class, and we'll be practicing everything that we learned on the video today. Okay? Great. Have a good day.